Hi, this is Mr. Roykson. I'm just going to take you through some acid-base problems. First thing, if you're looking at an acid-base problem, is if you're asked to find something like pH or concentration of hydrogen ions, or again, remember that can also be concentration of hydronium ions depending on how the question's worded. Really, the first thing is to look at whether or not it's a strong acid. So if you're given a problem and it's asking you to find, say, pH, and the acid is HNO3, right? Then you know that HNO3 is a strong acid, or you should know. And if you don't, you need to again memorize those strong acids, Bic pens. So you know that it's going to ionize 100%. And so again, we can show it also reacting with water. It's really the same reaction. The only difference is technically when you take nitric acid and you put it in water, it forms hydronium. And this should be a negative up here. So that's the first thing really that you need to recognize. So if they're asking you to solve for the pH and they tell you that it is a 3.0 molar nitric acid, right away you don't need to set up an equilibrium expression or anything. You just need to recognize that you're going to get 3 molars of H ions. So the amount of H ions, or the concentration of H ions, is going to be the same as the concentration of the acid when you're dealing with a strong acid. So if you're asked to find the pH, you would just do negative log of 3, which is our concentration. As I mentioned in class, you really have to be able to recognize strong acids and strong bases in order to be able to do these problems. So let's look at a different problem. What if you're asked to solve for the concentration of hydronium ions in a 2.0 molar solution of CH3COOH. Okay, and what you have to do is you have to recognize whether, again, this is not a strong acid, this is a weak acid. And when we're dealing with weak acids, they don't 100% ionize, so now you have to set up that equilibrium expression. So you have to set up the formula or the reaction, right? It's CH3COOH plus water, and that's going to get you an equilibrium reaction that is going to include acetate ions and hydronium ions. Again, as soon as you recognize that which is an acid, which is a base, you know that if it's an acid, it's going to be giving up a hydrogen ion to water, and if it's a base, it's going to be taking a hydrogen ion from water with those weak bases. So now that you have this, you can do your equilibrium expression where you put products, concentration of products over concentration of reactants, as we discussed in class. And then you set up once you have that, you'd set up your ICE table based on the Ka given. All right, now let's look at another example. Here's another example. Again, you have to decide whether it's a weak acid or a weak base, strong acid, strong base. Hopefully you recognize right away it's not one of the strongs. So now whether it's an acid or base, one of the clues is they give you a Kb value. If they give you a Kb value, then that's a way to recognize that this is going to be a base. That means when it reacts with water, it's going to take one of the hydrogens away from water, and you're going to be left with C5 H5NH plus OH ions. And this becomes positive because we have an extra hydrogen ion, which is positively charged. So now you have this. So let's say that the molarity of our C5H5N is 2 molar. Okay, then and we're asked to solve, what is the hydrogen ion content? Or what is the concentration of hydrogen ions? And so what you can do there is, set up your equilibrium expression. Your equilibrium expression is going to be Kb is equal to concentration of C5H5NH positive times the concentration of OH negative over the concentration of the weak base to begin with, C5H5N. And then you can set up your ice chart over here. And I'm just going to put this on top here of our ice chart. And this is a equilibrium, so the arrows can go in both directions. C5H5NH positive, and then plus your OH negative. And so an initial concentration change in equilibrium, your initial is going to be 2.0 molar. This is going to be 0. This is going to be 0. Your change is going to be the concentration of the C5H5N will decrease. Concentrations of the C5H5NH will increase by X, and so will the concentrations of OH. And then so your equilibrium line is going to be 2.0 minus X, and you're going to bring down your X and your X. And then you're going to plug that into your equation, so you're going to get X over X, or X times X, I'm sorry, over 2.0 minus X, and that's going to be equal to your Kb value of 1.7 e to the negative 9th. Now again, because this is such a small value, that means the change in X in the denominator is going to be removed, and so if we're going to multiply both sides by 2, and then we're going to have X squared. If we multiply both sides by 2, X squared is equal to 3.4 e to the negative 9th, and we're going to square root that value. And when we square root, when we square root both sides, we're going to get X is equal to 5.8 e to the negative 5th. So that is equal to, again, our concentration of hydroxide ions. So if you're asked to solve for pH, what you would have to do is, if you took the negative log of 5.8 e to the negative 5th, that would give you the the pOH value. So your 4.23 is your pOH, and if you subtract that from 14, you're going to get a final answer of 9.77 as your pH. So that's how you solve for those type of problems. So you have to recognize whether it's a strong acid, strong base. If it's not one of the strong, then it's a weak. Again, if they tell you it's a Kb, you know it's a base. If they were to tell you it's a Ka, then you know it's an acid. And then you would work that through the equilibrium, through the ice charts and the equilibrium expression. So I'd like you to try the problems, I believe, up to number 4 on this worksheet. The first ones, you're just setting up equilibrium expression. So again, look at whether it's an acid or a base, and then try those equilibrium expressions. And then the second part, you're actually solving for some of this. Remember, if it's a strong acid or strong base, the concentration of the acid or the base is going to be equal to the concentration of the hydronium ions or the concentration of the hydroxide ions. All right, we'll see you in class. Another example is CH3COOH, okay, and that's your acetic acid. So if you're being asked to solve for, say, the pH of this, you know it's not a strong acid, so you have to think about the equilibrium expression. You're going to get hydrogen ions, and you're going to get acetate ions. So in this case, in order to solve for this type of, oops, I got one too many H here. In order to solve for this type of reaction, you're going to have to set this up in an equilibrium expression. And that's when you need to know you have products, concentration of products, over concentration of reactants. So you need to be able to recognize that and be able to solve for that. Now, again, if you're doing some of these problems, how do you know if it's an acid or a base? Sometimes you might have to look it up. You might have to look it up in Google. Just do a quick Google search. The other ways to recognize it, if they tell you it's CH3COOH, and they might give you the Ka value. And so obviously if it's a Ka value, you know that it's going to produce hydrogen ions. Now if they give you, again, here's another example.